Hi, this video lesson is on imaginary and complex numbers. This PowerPoint will be located on the website, so if you choose to print that out, you may do so by opening the file and going to File, Print, and printing 3 slides to a page. That will create the handout that you see here on the right that I am using. Then you can kind of follow along with the PowerPoint as well at a later time. So in this video, imaginary and complex numbers, we're going to explore numbers that are not real. So in the complex number system, this is the system of numbers you already know about, but what you probably don't know is that it actually consists of numbers that are real and numbers that are imaginary. Yes, imaginary. Doesn't mean they're from imaginary land. It means they are numbers that have been established to help us do things in actually a third dimension. So real numbers you should already know about. Real numbers are made up of both rational and irrational values. Rational values are numbers that can be natural numbers, which are your counting numbers starting with 1, as in 1, 2, 3, 4, etc. Whole numbers include the set of natural numbers with the addition of the number 0. Integers are the positive and negative set of whole numbers. And rational numbers include all of these because these are numbers that make sense, but they also include fractions such as 1/2 because it terminates as 0.5, and maybe one like 1/3 because it's 0.3 repeating, and there's a pattern to that. So because these can be converted to decimals, decimals that have a pattern would be considered rational as well. Numbers that are not rational are irrational. They are numbers that tend to repeat without a pattern. And also include the numbers pi, 3.14, 15926, etc. It goes on, but does not terminate, as well as the number e, which we will also talk about a little bit later on in the course. Imaginary numbers, as you can see, are another set of numbers that make up the complex number system, but they have this number I. So we have to get used to seeing this and recognizing it not as a variable, but in fact a number. So next we're going to go ahead and define what I represents. So before, when you were taught to, say, solve quadratics and you ended up with a negative under the radical, for example, if you were doing the quadratic formula, ended up with x equals, and I'm making this up here, 2 plus or minus the square root of -5 over 4, we would say, oh, we have a negative discriminant value, and a negative discriminant, remember your discriminant is the b squared minus 4ac part of your quadratic formula. If you had a negative discriminant, we would say that you had no real roots. Well, remember, no real roots simply means that if they did not fit in the real number system, then they were actually in the still in the complex number system, but they were imaginary. And we'll talk about what that means in just a little bit. So now what you need to understand is that if you see the square root of a negative, where once upon a time we would call that no real solution, we actually can simplify it. So this next slide says that in the set of real numbers, negative numbers do not have square roots. So that's in the real number system. We don't have negative radicands. Remember, radicands, the number under the radical. Imaginary numbers were invented so that negative numbers would have square roots and certain equations would have solutions. These numbers were devised using the imaginary unit I. So this is definitely something that you need to remember, that I is actually the value of the square root of -1. So whereas before we would say, oh, that can't be simplified, there's no real solution to that, we actually can now simplify this as I. So it defines the imaginary numbers as the numbers bi, where b is a real number and I is the imaginary unit. So for example, if we had the number 5i, b would be 5, and that would be the real number component of our imaginary unit. There's also another property we need to understand that says that I squared is equal to negative 1. So let me talk about why that is. I squared, if you recall, means I times I. Well, that means the square root of negative 1, which we just defined, times the square root of negative 1. Well, recall, that means the square root of negative 1 times negative 1. Because we would be finding the square root, meaning we are looking for 2 of the same factor, we can see that we have one group of 2's, which means that I squared actually equals negative 1. Similar to how if we had the square root of 2 times 2, we would say that equaled 2, right? Because we had one group of 2's. Well, if we have one group of negative 1's, then it equals negative 1. So that's how I squared is equal to negative 1. If you need to hear that again, just press pause or actually go back and rewind and listen to that explanation again. So there are powers of I that we need to understand. We can see these definitions right here, that I, when we are talking about simplifying powers of I, that I to the first power will equal 1. I squared, like we just illustrated, equals the square root of negative 1 times the square root of negative 1, which equals negative 1. And I cubed equals negative 1. And that's because remember I cubed you can think of as I squared times I. And since it's to the first power, I squared times I adds to be I cubed using our properties of exponents. Since I squared we've already found equals negative 1, we've got negative 1 times I, and negative 1 times I would be negative I. So that's why I cubed equals negative I. I to the fourth we can actually think of as I squared times I squared. Remember, we already established that I squared has a value of negative 1. So if we were to simplify and replace I squared with negative 1 for both of these, then negative 1 times negative 1 would equal 1. So these are properties of the powers of I that you're going to need to remember. That I equals I squared is equal to negative 1, I cubed is negative I, and I to the fourth equals I. So we'll go back and review that in just a few minutes when we're simplifying. So let's go ahead and move ahead with learning how to simplify radicals when we have a negative radicand. To do this, we're going to use the property of the square root of negative numbers, which says that if r, meaning our radicand, is a positive real number, then the square root of negative r would equal I times the square root of r. The reason being is if you think about it, the square root of negative r is really negative 1 times r. If we separate this into the square root of negative 1 times the square root of r, then we would replace the square root of negative 1 with I, that's the definition of I, and then of course just have the square root of r. Because this is possible, we know that basically any time that we have the square root of a negative, that negative 1 is a factor, and because negative 1 is a factor, the square root of negative 1 is I. So basically what you're going to hear us say is that if you have the square root of negative, make it positive and put I out front. Notice if we have the square root of negative r, we end up getting I square roots of r. So this value, your radicand, becomes positive, and it can be simplified if possible. But just remember to put a I out front if we have negative under our radical, and that would be completely simplified. So next, let's look at a couple of these examples. We have here that the square root of negative 3 is equal to I square roots of 3. So let's make sure we're understanding how to apply what I just explained. The square root of negative 3 would be the square root of negative 1 times 3, meaning the square root of negative 1 times the square root of 3. Because the square root of negative 1 is I, we get I square roots of 3. Exactly what we have here. For this next one, we have the square root of negative 4. So basically, if you're understanding what I'm saying, then you'll recognize that because we have a negative here, we can go ahead and put I out front, And then if the radical can be simplified, we should. So we know that this is 2 times 2. We have a pair of 2's. So we end up with 2i. Notice that our answer is in the form bi, where b is your original part and I is your imaginary part. So please, the same as we would, say, list 2x with 2 as our coefficient in the front, please go ahead and list your real number first. So that would be 2i. All right, next, let's go ahead, and it'd be nice if you could try to simplify these or make sense of these. If you were playing the presentation, the problems would pop up without the answers. But I'm just going to write these to the side, and we'll discuss these real quick. So we're going to go through a few examples here. All right. So if we consider these, we would apply what I just said, which the square root of a negative means we can stick I out front and then leave the radicand but simplify it. Since 7 is a prime number, we are done. It's that simple. This means the opposite of the square root of negative 36, which would be the opposite of, watch what I'm going to do, circling this I, I'm going to put I out front and make this a positive number. We should recognize at this point that the square root of 36 is 6. So our final answer would be negative 6i, or the opposite of 6i. So just remember, if you have a negative out front, to keep it there. Okay? Next, we have the square root of negative 160. Because of this negative, I'm going to go ahead and put I out front. And then I need to start simplifying the square root of 160. If you have any trouble at all with simplifying radicals, we have a video posted as a review from Math 2 on how to simplify radicals. So please make sure you check the website for that video if you need help simplifying radicals. So once we get to the point where we recognize that we have one that's a square root, a perfect square, I'm just going to put the square root over 16, because we know the square root of 16 is 4. But our factors of 10 are prime, which get multiplied together. 2 times 5 is 10. Just don't forget to make sure you put your I after the real number part out front. So that would be 4i square roots of 10. Next, we're going to look at simplifying a few more. Again, if you'd like to pause the video and try these on your own, that would be awesome. The first one is the square root of negative 5. So hopefully you recognize, you can see all these steps here in the PowerPoint, but this would simply be I square roots of 5. If you have the opposite of the square root of 7, this would be the opposite of this value, square root of negative 7 being I square roots of 7, which would simply be negative I square root of 7. Next, we have the square root of negative 99. So I'm going to go ahead and put my I out front. And then we need to break down 99. It is divisible by 3 and 33. And then 33 is 3 times 11. Because we have a pair of factors, that will come out, giving us 3i square roots of 11. So hopefully you're understanding now how to simplify square roots when we have negative radicands. Next,